Section 12.1. Our objective today is I can find the lateral area, total area, and volume of right prisms. So a right prism is like a box, or a cube would be a right prism, where all the sides are perpendicular to each other. Okay, and then there are a lot of different terms that we need to know. First of all, we need to know what a base is. So the base lie in parallel planes or in congruent polygons. So in my picture, the shaded areas here are the bases. So in a prism, there's always two bases. A lateral face is all the faces that are not bases. So pretty much it's the vertical parallelograms. And they always intersect each other in what we normally call, we just say the edge or corner. In geometry, we call those the lateral edge. So this is a lateral edge, and this would be a base edge, okay? And notice that this is also a lateral edge, okay? A right prism, all the lateral faces are rectangles, okay? An altitude is a segment joining the two bases, two base planes, and is perpendicular to both. So we could say that this is the altitude, but in a right prism, the lateral edge is also the altitude, or also the height. Okay. So the height is just the length of the altitude. The lateral area is the area of all the lateral faces. All right, so that brings us to our first theorem. And the theorem says the lateral area of a right prism equals the perimeter of the base times the height of the prism. So in other words, lateral area equals perimeter times height. And again, we can just find the area of each of the lateral faces and add them up, but this is a quick way to do it. Then we have what's called total area. Total area is defined as the areas of all the faces. In other words, the area of the lateral faces and the two bases. So the theorem says this: the total area of a right prism equals the lateral area plus both the base areas. And so we abbreviate that. Total area is equal to lateral area plus 2 times the base area. Notice this is a capital B, and the capital B means it's the base area. Okay? And then the final theorem is that of volume. So the volume of a right prism equals the area of the base times the height of the prism. Okay, and so volume equals base area times height. Remember, the capital B stands for base area. Okay, so let's look at an example here. Okay, so let's say I have a prism whose bases are right triangles. Okay, and let's say that we know this is 8 centimeters, this is 6 centimeters, and we want to know that, and it has a height of 12 centimeters. Okay, so find lateral area. Okay, well, lateral area is the perimeter times the height. So we need to know what the perimeter is, so we need to find what x is. So because these are right triangles, we can just use Pythagorean theorem. So 8 squared plus 6 squared equals x squared. So 64 plus 36 equals x squared. 100 equals x squared. So 10 equals x. Okay, so lateral area is equal to 8 plus 6 plus 10, which represents the perimeter, times the height. Whoops. And in this case, we know the height is 12. So we get 24 times 12, or 288 centimeters squared. Okay, now let's find the total area. Well, total area is lateral area plus 2 times the base area. So we already have the lateral area, so we have to find the base area. But since those are right triangles, the legs are the base and the height. So the area of the triangle is equal to 1/2 8 times 6, or 24 centimeters squared. So lateral area was 288 centimeters squared plus 2 times 24 centimeters squared. Okay, so it's 288 centimeters squared plus 48 centimeters squared. And so that gives us 6, is that right? 8 and 8 is 16, 1, 12, 13, 1, yeah, okay. So the total area is 336 centimeters squared. Now let's find the volume. Okay, so the volume is the base area times the height. Well, the base area is 24 centimeters squared. The height was 12 centimeters. Okay, and so the volume is going to be 288 centimeters cubed. Volume is always cubed. So there are some quick examples, and and we are done.